Okay, so we're going to continue now with the examples for this section. So our examples in this case, and this might be a good time for you to pause the video, or if you haven't already, do the examples yourself and then come back and check them and see if you know how to do them based on what we talked about before. All right, so here we have this first one. Tell whether each segment is best described as a chord, a secant, a tangent, a diameter, or a radius. So in this particular case, segment AH intersects the circle in exactly 1 point, which makes it, in this case, a tangent. We've defined a tangent as being a line. You'll find that a tangent can be a segment, and we'll look at that later in the chapter, but a tangent can be a segment as well. A lot of times here you'll be given 4 segments just so that it's not giving away which one's a secant or which one's a tangent by the ones that are lines. So those can be segments as they are here. All right, our second one, EI, and I remembered after I copied these that was supposed to be changed to a J. I didn't like that the I was appearing a little bit too much like a 1. All right, so segment EJ, in this case, connects point E to point J. A segment that connects 2 points on the circle is what we refer to as a chord. C, segment DF, there again, it's going to be a chord. And lastly, segment CE from the center to a point on the circle is what we refer to as a radius. Now, in terms of problems here, we mentioned that a tangent could be a segment, it could be a line. The same is true for secants. So a secant could be considered a segment connecting 2 points on the circle. So here if you had secant, or here if you had secant, that would also be acceptable. In the terms of what you're going to see later in the chapter, the secants and tangents will be treated as segments more than they are as lines. All right, and number 2, tell whether the circles are internally or externally tangent. So we have a line in this case that is tangent to both circles, and we determine if it's internal or external by looking at the segment connecting the centers of the 2 circles. So let's take a different color here. We're going to identify or approximate where the center is here, and we'll approximate where it will be on this circle. It's going to be somewhere like here. Okay, so if I were to draw the segment connecting these 2 centers, remember an internal tangent intersects that segment, whereas an external tangent does not intersect that segment. So in this case, our tangent line down here that's intersecting both the circles at 1 point is not intersecting that segment, which makes it an external tangent. And that takes care of our first set of notes. Your assignment for this one is the first worksheet in your packet.